All right, folks, welcome back. We are going to finish up the chapter today. We're going to do the second part of 47B, solving radical inequalities. So it is much like what it sounds like. We're going to jump in just like yesterday and just go right into some problems. All right, the idea behind these, we'll have something now like this, where we're told to solve, given square root of 6x minus 5 is greater than 4. All right, now we can go ahead and solve just as if this was an equal sign to start. All right, and this is the first step I call is finding your possible solutions. Just like before, when if you think back to what we did in the equations with radicals, when we solved, those were only possible solutions. We had to check them to see that they actually made our statement true, right? Again, we could create some extraneous solutions in these. In fact, we can create infinitely many of them if we aren't careful. So first thing we're going to do is solve this just like it was an equal sign here. This is already isolated, so we are just going to eliminate it. Squaring both sides, I would get 6x minus 5 is greater than 16. Going to solve. All right, solving this, I add 5 to each side, and I get 6x is greater than 21. And finally, when I divide by 6, I get x is greater than, well, 21 divided by 6, 3 goes into both of those. So what do we have? 7 halves. So x greater than 7 halves. So thinking of this on a number line, all right, what I want you to think of is if we had this on a number line, this would be an open circle at positive 7 halves. So we're at 0 here. Let's say 1, 2, 3, and 4. So 7 halves is in between here. And we're doing x greater than that. So we'd have an open circle and an arrow going this way, right? Now, we've got to look at one thing about this. Just like with our other one where we get extraneous solution, there might be some parts of this set, or maybe everything in this set, might not make this true. And so what we have to do, we can't really test it because there's infinitely many things in this set, but what we can do is check for the domain of the radical. All right, this radical itself, the square root of 6x minus 5, has a domain because we know we can't take an even root of a negative number without getting an imaginary result, right? We want real number solutions. So in the real number set, we have to have where the domain for this radical is where 6x minus 5 is positive. In other words, greater than or equal to 0, right? We can take a square root of 0. We can take a square root of any positive number. So we want 6x minus 5 to be a positive number or 0. That's what this says. So now we have to solve for the domain and make sure that everything, we have to find what part of this solution is in the domain, I guess is the best way to put that. All right. So I'm going to add 5 to each side. And I get 6x is greater than or equal to 5. Dividing by 6, I would get that x is greater than or equal to 5/6. Now, where is 5/6 in relation to that 7 halves? Well, 5/6 is back here just below 1, right? So for this domain, what we're saying is for the domain to have values that work, we have greater than or equal to, sorry. So it's closed circle going this way. So the entire set of solutions is in the set of domains. So we just use this as our set of solutions. If we had found, for example, that x had to be greater than 4 by domain, we would have just used x greater than 4 because that part of the set would be the part that works. But we found that it was greater than 5/6. Anything greater than 5/6 would work. For our particular solution, we needed something greater than 3.5. So we use that 3.5 for the set of all solutions that are in the domain is what we're basically looking at. All right, let's do another one. So let's do the square root of 2x minus 3. Whoops, I went way too far with my square root. Is less than 5. So again, we always check, is it isolated? Yes, it is. So we work from there. And squaring both sides, we get 2x minus 3 is less than 25. Add 3, and I get 2x less than Well, we get 28 and divide by 2, and I get x is less than 14. So I have that to start. That is my possible set of solutions. Now I want to look at the domain. And I would always label it myself just because I want to remember which one was which. Domain is all the things that make just this side of it true. This is what makes the equation or the inequality true. I want to use the overlap. So let's see, the domain is going to be where 2x minus 3 is greater than or equal to 0. That's when 2x is greater than or equal to 3 by adding 3 to both sides. Divide by 2, I get x greater than or equal to 3 halves. So again, if you have trouble visualizing this, you can always make yourself a number line and see where the overlap is. So if we start with the solutions, x less than 14. So if this is 0, this is 14, we want x less than it. So it's going to be an open circle going this way. Now this one is the domain. This is all the values we can use. X greater than 3 halves. So if 3 halves is here, we're saying greater than or equal to this way, everything that way. So where's the overlap? Well, take a look at that. Our set of solutions that are in the domain would start at 3 halves, including 3 halves, and they would go all the way until we hit this top part here. So we would say that as x is greater than or equal to 3 halves, but less than 14. That would be the set of solutions here. Everything that is in the solution set, but is also in the domain, the red here. Everything below 3 halves is outside the domain. We get negative numbers under the radical is what that shows you. All right, one more. Let's look at the square root. Whoops. Oh, that's all right. So the square root of 4x plus 5 plus 2 is less than or equal to 12. So first thing, we've got to isolate it. So we're going to subtract 2 from both sides. And we get the square root of 4x plus 5 is less than or equal to 10. So now to solve this, we would look at squaring both sides. We square, we get 4x plus 5 less than or equal to 100. And subtract 5, 4x less than or equal to 95. And that makes, when I divide by 4, x has to be less than or equal to 95/4. I'm just going to leave it there. I can't reduce it. So that is my set of solutions. Now I'm going to look at my radical. I got to have 4x plus 5. Again, this is my domain. What x's can I use? So this has to be greater than or equal to 0. So we get 4x is greater than or equal to negative 5. That makes x greater than or equal to negative 5/4. So if x is greater than or equal to negative 5/4 in the domain and x is less than 95/4, once again, what can we do? Well, look at it. You don't have to draw a number line. I just think it's easier to demonstrate to you this way. If I look at this one, I would have 95/4. All right, a little less than 25, right? So a little more than 24, something like that. Let's see. So, yeah. Anyways, less than or equal to that goes this way. And this one, greater than negative 5/4. Negative 5/4 starts down here. And it would be everything going that way. So really what it comes down to is everything between these two values, inclusive of those two endpoints, right? So we would say the solution is x between negative 5/4 and up to or greater than negative 5/4 and less than or up to 95/4 inclusive of those endpoints. And that would do it. So that's what we're doing with this section, guys. Same process. Solve like you would normally, as if it was an equation, and then look and see what part of that solution is in the domain. That's kind of like our checking that we did with equations. And that's it, guys. That is the end of the chapter in terms of new material. So finish this off. Have a wonderful day. We'll talk to you tomorrow.